Question number 16 says we have a packet of matchboxes. It contains 12 gross matchboxes. That means 144 matchboxes. And the dimensions are given. And the question also says the length and breadth of one matchbox. The length is 5 cm, breadth is 3.5 cm, and the height is unknown. We need to find this height, the height or width of one matchbox. Now, the volume of one packet, that means 144 boxes, is 28 into 15 when all the dimensions are converted into centimeter. And then 9, okay, so this is centimeter cube. This is the volume. The volume of one matchbox is equal to 5 into 3.5 into h centimeter cube. Therefore, we can say the volume of 144 matchboxes equal to 144 into 5 into 3.5 into h centimeter cube. Now this volume should be equal to this volume because 144 matchboxes are fitted into this bigger cuboid. Therefore, these two volumes are equal. Therefore, 144 into 5 into 3.5 into h is equal to 4 . 1.5 centimeter. So this should be the height of one matchbox. Now let us proceed to question number 17. Question number 17 says, half of a cuboidal water tank with length 2.1 meter, breadth 1.5 meter is filled with water. If 630 liter of water is poured more into the tank, then let us calculate and write the depth that will be increased by. Okay, so the tank was half filled. We added 630 liter of water more into it. So we need to find out the height we need to find out the increase in water level. Okay, we need to find out the increase in water level. So this is our tank. Okay, so it was half filled, it was filled up to this point. Now when extra water is added, the water level goes up and it reaches this point. So we need to find out this length. Okay, the rise in water level, this is what we need. Now let us calculate. So we are going to calculate the volume of water in this part. Okay, so now we are going to find out the volume of water from this point to this point. Okay, this is also a cuboid. Therefore the volume of water therefore the volume of water contained between the final and the initial water level. This is the final water level and this is our initial water level. So we are trying to calculate the water contained in this region. That is, this part, this middle part is also a cuboid with length 2.1 meter, that means 21 decimeter into 1.5 meter, that means 15 decimeter into, let us say this is h decimeter. The rise in level be h decimeter. Okay, so this is dcm cube. This volume is actually equal to this volume. So we can equate these two volumes. Therefore, two decimeter. Therefore, the depth that will be increased is 2 decimeter. So 2 decimeter rise in water level. Now let us proceed to next question. Now question number 18 says the length and breadth of a rectangular field of the village are 20 meter and 15 meter respectively. For construction of pillars in the four corners of that field, 4 cubic holes having length of 4 meter are dug out, and the soils removed are dispersed. Okay, and the soil removed are dispersed on the remaining land. Let us calculate and write the height of the surfaces of the field that is increased by. Okay, I hope you have understood this question. Now let us look at the diagram. Okay, let us consider this is a rectangular field with length 20 meter and breadth 15 meter. Now for construction work we are digging out 4 holes which are cubes. Okay, and the side of a cube is 4 meter. So we are removing soil from these places, and that soil is dispersed in the remaining field. Okay, that soil is dispersed in this area. Okay, in the shaded region. Because of that, the height of the field is increased. So we need to find out that height. So when the soil is dispersed in the remaining field, then its height is increased. Now we can consider that this length is 7 meter. Why? Because this part is 4 meter and this part is 4 meter. So 15 minus 8 is equal to 7 meter. So this part is 7 meter. And this part will be 12 meter. Why? Because 4 meter and 4 meter, this length is not being used. So 20 meter minus 4 meter and again minus 4 meter. So 20 minus 8, 12 meter. Now this is actually a 3D diagram which cannot be drawn properly on a paper. You have to imagine it. After dispersion of soil, the height is increased. Okay, the ground is elevated. So that height is h meter. Okay, so we can consider the whole field we can divide the whole field into three parts. This is part 1, this is part 2, and this is part 3. These 4 holes are not being used. Okay, so this is our part 1, this is our part 2, and this is our part 3. The height is increased uniformly for these 3 parts. That means the height of this portion will be equal to height of this portion and the height of this portion. The soil is dispersed uniformly. So this is our first cuboid and this is our second cuboid. So and this is our third cuboid. So the volume, therefore the volume of three parts where the soil is dispersed is equal to, so first we are calculating the volume of this part. So this is 4, this is 7, so 7 into 4 into height is h plus the volume of the middle part. So this is 12 into 15, 12 into 15 into height plus the volume of this part, that is 7 into 4 into h again. So this is the volume of the removed soil. We have determined the volume of these three parts: volume of first part plus volume of second part plus volume of third part, and this volume is actually equal to the removed soil. This volume is equal to the volume of removed soil. And the volume of removed soil is volume of 1 cube into 4, because we have 4 cubes. So 4 into volume of 1 cube, which is 4 cube. Okay, so this is our equation. Now we need to solve it for h. So this is our answer. So the height is raised by 1.08 meter approximately. This should be our answer. I hope you have understood this question. Think about it carefully. You will definitely understand. Thank you, friends. That's all for today. Tomorrow we shall come with another video where we shall be solving the rest of this chapter. And if you like my videos, then please like, share, and subscribe. Thank you.